Now, today we want to look at perpendicular lines. Now, here we have two lines. We have line CA and line AB. With the line AB passes through 2 points, point 28 and point 64. So let's get the gradient of line AB. Gradient of line AB will be the change in y, that is y2 minus y1 over x2 minus x1. Now, if we take this point to be our point P1 and this one to be our point P2, then from here we'll get the coordinates for y is now 4. Therefore, 4 minus the value of y in point 2 is 8 over the value of x here is 6 minus 2, and that is negative 4 over 4. And therefore, the gradient will be negative 1. So let's attempt to get the gradient of line CA. Now, gradient of line CA will also be change in y, that is y2 minus y1 over x2 minus x1. So let this be our points P2, P1, and this one be our point P2. For the line CA, this is the point P2. So for us to get gradient will be the change in y, that is 8 minus 1, 8 minus 1 over the change in x is negative 5. No, P2 is this, that is 2 minus negative 5. And therefore, the gradient here will be 7 over 7, and that is 1. So if we multiply the gradient of line AB and the gradient of line CA, then we have negative 1 times 1, and that one is giving us negative 1. Now, this is a property that is very important. Now, when you multiply the two gradients of two lines and you get negative 1, then these lines are said to be perpendicular. In other words, the two lines are meeting at 90 degrees. Therefore, we can make a conclusion that if two lines are perpendicular, if two lines are perpendicular, then the product of their gradient is equal to negative 1. So this is a very important property in dealing with perpendicular lines. We are saying that if two lines are perpendicular, then the gradient of those two lines will be equal to negative 1. So let's look at an example. A line L1 passes through points negative 1, 7 and 5, 6. And is perpendicular to line L2, which passes through point 0, 1. find the equation of line L2. So in this case, we are told that line L1 passes through point negative 1, 7, and 5, 6. So we can get the equation of line L1. Or we can get the gradient of line L1. Gradient of L1 should be, if this is our P1 and this is our point P2, will be change in Y over change in X, X2 minus X1. And if that is our point P2, then this is the value for Y2, that is 6 minus 7 over 5 minus 1, which is negative 1 over 6. So that is the gradient of L1 is negative 1 over 6. And you're told to find the equation of L2, which is perpendicular to L1. Therefore, if L2 is perpendicular to L1, then gradient of L2 times gradient of L1 should give us negative 1. And therefore, we've got the gradient of L1, which is gradient of L2 times negative 1 over 6 should be equal to negative 1. And therefore, gradient of L2 is 6. We multiply both sides by 6 and divide by negative 1. So gradient of L2 is 6. Now with this gradient and the point through which L2 passes, then you can now get the equation of L2 by taking a general point. Take general point xy and the point through which line L2 passes, which is 0, 1, and use these points to find gradient and equate to the gradient of L2 that you've got there. So y minus 1 over x minus 0 should be equal to 6, and therefore y minus 1 is equal to 6x, and y is equal to 6x plus 1. So that will be the equation of line L2. So up to there, we can now see how the concept of perpendicular lines is applied in finding the equation of another line that is perpendicular to the previous line. So you can attempt this at your free time. If a line L3 passes through point 2, 2 and point 19 and is perpendicular to line L4, which passes through point 1, negative 4. So find the equation of line L4. So you can attempt that. Line L3 passes through point 2, 2 and 19, and that line L3 is perpendicular to line L4, which passes through point 1, negative 4. So find the equation of L4. I think that will give you some little practice. Thank you.